Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome to all of you in the online physics lecture series for 10th class. This video will cover the initial topics of chapter number 1, which is simple harmonic motion and waves. The topics that are going to be covered in this video are definition and explanation of simple harmonic motion. Some terms which are associated with simple harmonic motion. For example, vibrating body, restoring force, and time period. Finally, we will also discuss motion of mass attached to a spring as an example of simple harmonic motion. We had already studied about waves. A wave is defined as any disturbance in a medium, and mostly a wave is produced by a vibrating body. A vibrating body is defined in following words. A body is said to be vibrating if it moves back and forth or to and fro about a point. This point is actually the mean point or the rest position of the body. Another term which is associated with vibration is oscillation. Let us take an example of a simple pendulum, which is vibrating about its mean position or its equilibrium position. The path of this vibrating pendulum is shown as a blue line. We can also take some other examples of a vibrating body from our daily life. For example, a tuning fork or the strings of the guitar. Another term associated with simple harmonic motion is restoring force, which is defined as a force which always pushes or pulls the object performing vibratory or oscillatory motion towards the mean position or the equilibrium position. Here in this picture, the red plus signs shows the extreme position of the body, whereas the two black lines are showing the equilibrium or the mean position of the body. The blue line is showing the path of the vibrating body. But you see that the red arrow and the blue arrow, both of them are showing the restoring force. When the bob of the simple pendulum is at the right extreme position, then the restoring force is directed towards the mean position, which is given by red arrow, and vice versa. We must know that restoring force is sometimes given by negative sign. It is always directed towards the mean position, and its magnitude is always equal to the applied force. Some other related terms to simple harmonic motion are vibration, time period, frequency, and amplitude. Time period is actually the time taken by the vibrating body to complete its one round trip or one vibration. Frequency is defined as the number of vibration or cycles of a vibrating body in 1 second. Frequency and time period, both of them are reciprocal to each other. And finally, amplitude is defined as the maximum displacement of a vibrating body on either side from its mean position. Now we are in a position to define simple harmonic motion. We will go towards the explanation and definition of simple harmonic motion by giving the three examples. Number 1, the motion of mass attached to a spring on a horizontal frictionless surface. Number 2, the motion of a ball placed in a bowl. Number 3, the motion of a bob attached to a spring, which is actually the simple pendulum. Simple harmonic motion is a type of vibratory or oscillatory motion. It is such a type of motion in which whenever a body vibrates about a fixed position, which is commonly known as the equilibrium position, then the acceleration produced is directly proportional to the displacement of the body from the mean position, and this acceleration is always directed towards the mean position or the equilibrium position of the body. Motion of mass attached to a spring. As we already know that motion of mass attached to a spring is a type of simple harmonic motion. But before explaining, we must know about the Hooke's law, which we had already studied in 9th class. According to Hooke's law, the strain produced is always directly proportional to the applied stress. So, if the spring is stretched or compressed through a small displacement, which is represented by suppose x from its mean position, then it exerts a force on the mass which is attached to the spring. So according to Hooke's law, we are able to write it in mathematics like F is equal to minus kx, where k is spring constant, F is force, and x is the displacement. As already discussed, that k is the spring constant and it is defined as the ratio of force to displacement. We also know a relation from our 9th class studies, that is F is equal to ma. This is relation for second law of motion. So by putting this value of force, which is ma, into the equation of k, which means that equation of spring constant, so we get k is equal to minus ma over x. By rearranging this equation, we get a is equal to minus k over m into x, where k over m are constant. So we can say that a is proportional to minus x, which means that the acceleration of mass attached to a spring is always directly proportional to its displacement from the mean position, which means more the displacement, more will be the acceleration, but is always directed towards the mean position. So here we come to the conclusion that motion of a mass attached to a spring is actually simple harmonic motion. In the start of our lecture, we have discussed some of the terms which are related to simple harmonic motion, in which time period is one of the term whose formula is T is equal to 2 pi under root m over k. This formula of time period is actually for mass attached to spring. and this time period depends upon the mass and the spring constant of the spring. Similarly, we have also formula for the time period of simple pendulum, which is t is equal to 2 pi under root L over g, where L is the length of the string and g is the gravitational acceleration, whose value is 9.8 meter per second square. So finally, at the end of this lecture, I am leaving you with this assignment in which you have to solve a numerical and you have to solve these three questions. It would be better if you solve this numerical similarly for mass attached to a spring by changing the values as required. Thank you so much.